in section 14.2, we're going to talk about reflections and glide reflections. So a reflection, or sometimes called a flip, is described like this. A point P is reflected over a line L, and its mirror image, the image, right, is point P prime. Line L is called the reflecting line. If the point is already on the line, then it doesn't change. It's its own image. If the point is not on the line, then L is the perpendicular bisector of its segment, P prime. A reflection also reverses the orientation of the pre-image. And the last feature is that a reflection is in fact an isometry. If you'll remember, isometry just means it preserves distances and lengths, sizes, shapes, all that stuff. So a couple of things to just sort of describe. We'll go in order. So imagine, I'll draw some pictures here. You have a grid. I've got a grid on my screen, so we're just going to go with it like this. And we have the point P, and it's just right here. It's sort of in a random spot on purpose. And we're going to let this vertical one be our line of reflection. I need one line, so it's the one I'm going to use. So what I'm going to do is I'm going to flip this, right, there's that word flip, to the other side of the line, the same distance away. Right? You're going to take it over here, and you're going to flip it over to here. Right? So several things happen when you do that. If the point is the way I drew it, it's not on the line, then what happens is that there's a line segment that we could call between them P prime. So this is my original P, this is P prime. And that line L is the bisector of it, cuts it in half. And of course it has to, right? Because that's the whole point, is it has to preserve distances. So the distance from the line to point P and the distance from the line to point P prime have to be the same. And it creates a perpendicular there as well. Okay? So as we're thinking along that line, if the point had actually been on the line, clearly, if you reflect it over the line it's already on, there's nowhere for it to go. So that's what it's talking about on this sort of second bullet point right here. Okay, so I think that takes care of all of these. This idea of the reflection reversing the orientation of the pre-image. So this would be like the idea that so Kinsey, you're going to do an exercise with me. Hold up your right hand. And if I hold up my right hand, we're reflecting one another, but it doesn't work, right? I mean, that's your right hand and this is my right hand, but they don't mirror image each other. So if I hold up my right hand and I want the mirror image, you would actually hold up your left hand. So it reverses the orientation. Does that make sense? Okay, so that's what it's talking about on the next bullet point. And then, of course, isometries preserve distance. So we're going to talk about some reflections now. The first reflection we're going to talk about is about folding. So one way to construct reflections is to fold along a reflecting line. And you've probably done something like this before. I know Valentine's, when you're making a heart, is a lot easier to fold the paper in half and to draw half the heart, right? And then to cut that out, and then you have this beautiful symmetric heart. Because if you try to freehand it, you're probably not going to get something that's quite symmetric, even if you're a good artist, right? So this is what the idea is. Folding along the line, reflecting it to the other side. You can use tracing paper. You could use most copy paper's thin enough that you can still see it that way as well. And you get the image and the pre-image. Okay, so that's one way. Tracing paper. So tracing paper can be done as well without even a fold. So if you take tracing paper, the book likes to use this sort of brownish color for its tracing paper to differentiate it so you can tell. So imagine if you had the white paper is the paper underneath, and that's where the triangle's actually drawn. Okay, the triangle's drawn on the white. And then you're laying this brownish colored tracing paper on top to distinguish. And then you can actually trace it, right? You just trace it on top, and you physically flip the paper over, and it lands right here, and then you can retrace it underneath. Okay? The thing you have to be careful of is the distances, right? So the distance from this point X, let's say, to the point B has to remain the same down here, and it will be the same over here from X to B prime. You can also see in the way that this is drawn, the flipping of it, how they're flipping the letters themselves. So you see here the letter B on the top of my triangle. When it actually flips the image over here, it looks like a B backwards with a tilt the wrong direction and all that kind of stuff. So they've actually drawn in even the letters flipped. So you can see what that looks like when you flip those letters. So that's what happens if you're thinking about it in terms of tracing paper. Another way of thinking about it has to do with creating a dot grid. Now, with your dot grid, you can do the same sorts of things where you're folding along the lines, where you're doing tracing paper, but it does give you some guidelines if you're not using one of those about how to make the drawing. Okay? So as I'm flipping along my line, or around my line, we can actually think about the individual points themselves. For instance, this point right here doesn't move. Why? It's on the line. Okay, so my image is going to include that same point. Everything else has to actually move from where it was to somewhere new. So like this point right here has to actually flip over the line, and you can imagine it's going to go right there, right? This point here has to flip to here. How do I know? Well, because if I were to draw the line across it, right, the perpendicular line, that's where I would land. Let's try a couple more with some colors. How about this point right here? Well, it has to flip right here. Again, because if you think about drawing that blue line through, I'm preserving my distance. It's the same distance away from line L. And then my last one, we'll make green, would actually have to come to right here. So it would have this point right here. We connect our dots just like in Chili's when you have your Chili's menu, right? Connect the dots. And this is my image over the line. And I did it point-wise. It looks like the start of like a pinwheel or something on my screen, doesn't it? It's lovely. All right, so that's a reflection. So Elizabeth, you asked some questions back in the last section about half turns that did some interesting features to the signs, right? It changed some signs. We have some of those that happen with reflections as well. So a reflection over the x-axis changes the y values. That should make sense. If you're above the x-axis and you flip to below the x-axis, then your y value changed signs. A reflection over the y-axis, if you're on the right-hand side and you flip over the y-axis, you'll be on the left-hand side, so your x value changed signs. The other two are a little bit trickier because they're visually not quite as clear to us. They're reflections over the line y equal x and the line y equal negative x. So if you'll remember from like an algebra course in terms of equations, if this is your xy coordinate plane, the line y equal x is this one, right? And then y equal negative x would be the same thing but going in a negative direction like this. So those are the other two lines that it's talking about. And what happens when you reflect along those lines is it actually changes the ordered pair. So instead of being AB, it's now BA. And if you're reflecting across the line with the negative x, instead of AB, it's now negative B, negative A. So it switches x and y. And the second one switches the signs as well. So given that those pieces of information, we're going to apply them to a specific point. So the specific point that we're given in example 2 is the point 2, negative 3. So if I'm reflecting in the x-axis, what's going to change? The y is going to change. So what do I get as my ordered pair? Yep, 2, 3. And if it bothers you to actually write this out from like this equation-ish kind of standpoint, draw a picture. You'll get there quick if you draw a picture too, because you can see what's going on. So don't hesitate, even if something doesn't say you have to draw a picture, to do so if it's helpful to you in making that determination. The second one, the y-axis. So if I'm reflecting over the y-axis like this, what's changing? The x value is changing. So what would my ordered pair be? -2, -3. So it's going all the way time back to the original point, not to the point I just did. Back to the original. What would I do to reflect over the line y equal x? Okay, you're close. Close? -3, 2. So reflecting over the line y equal x, I feel like I should draw a picture at least of this one. I'll do that here in a second. Just switches x's and y's. Okay, let's draw that one because I do want to make sure that you believe me. Didn't just make it up. So here's my coordinate axis. I have the point 2, -3, which would be down here. And I'm trying to flip it. It helps that there's kind of a grid on my screen. I'm trying to flip it along the line y equal x, which is here. So if you can imagine, you've got to do a perpendicular line across like this, but it has to be the same distance away. So when we do that, we're going to land at, I didn't draw it super well, did I? Sorry, my grid line's a little bit off. You can at least see how my, did I draw it? Yeah. You can at least see how my ordered pair becomes a negative x value and a positive y value, right? Because I've landed in the other coordinate quadrant, right there. My grid's a little bit off, but I do land at -3, 2 if I had drawn it well, which would have been a little bit higher than what I drew. I can't get there. Go ahead.
Would you be like counting from that point, how far away it is from the line, and then
Yeah, so to be honest, it's got to be the same distance from x's and y axes as originally it was. So you can count it like that. But you could actually calculate the slope too. So like this slope is positive, right, of my original line that I drew here, which means that if I need the perpendicular slope, like we talked about, I think we did in chapter 8.5, that these negative reciprocals, didn't we do that in 8.5? Talk about negative reciprocal slopes? Okay, so this slope would be a -1. So my slope would have to actually do the same thing. I end up, let me draw it again so I can get a better picture of it. Right there. Yeah, that's the right angle I was looking for as well. And there's my point right there on the quadrant 2. Come on, change colors for me. So I have -3 and +2. So it swaps x's and y's. You might remember from an algebra course somewhere along the way that there is a process we switch x and y's, and we do it to find inverses. Does that sound a little bit familiar? You switch the x and the y, and then you solve for y, and it finds the inverse of whatever you had before. That's what we're doing here. When we're reflecting over the line y equal x, we're finding the inverse of the point. It's the reflection of the point for what we're talking about here now. And then if I do this with the line y equal -x, it switches the points as well, but it also changes the signs. So now I have that +3 and that -2 that we were thinking about before. Any questions on that one? All right. This is actually a page out of a child's textbook. So this is early middle school. And it's the geometry component that you would see. I think that it's from a 7th grade book, if I remember right. And it wants you to decide if each pair is related by a slide. That's what they're calling a translation, right? A flip, that's what we're calling a reflection, or a turn, which we called a rotation. So they've changed the phrasing a little bit, but they mean the same thing. And then they want us to describe it. And in some cases, there's more than one correct answer for the description of what's changing. You sometimes have more than one thing you can write down. So let's actually look at number 1. We'll just go in order. Number 1, if you talk about going from this dark purple on top and then your image is the lighter purple on bottom, what would arrive there? I mean, what could you use to get there? I don't think slide's going to work because slide has to preserve orientation, which means the direction doesn't change. So you can almost see like the diagonal side on top is now a diagonal side on bottom, right? This right here on top, it's sloping down, becomes this line on bottom. And if I were doing a slide, that wouldn't happen. So what else might it be? A flip, or what we're calling a reflection, right? It is a flip. We're going to take the image that we are given, like the picture that we're given, and we're going to actually draw in the line of reflection. So where will the line of reflection be to turn one of these shapes into the other one? Yeah, in between them, horizontal, right? Yeah, it's going to be horizontally in between them. So something like that. That would be my line of reflection, give or take. How about number 2? They draw an arrow to show you which direction they're wanting you to go. They're wanting you to go from the orange rectangle to the red rectangle. What's going on there? It could be a turn. That's one option. If it's a turn, it says that we're supposed to describe it. So let's start with turn. How would this be described? Fabulous. It's a turn 90 degrees clockwise. That'll work. Is there anything else that it could be? I know it's got the arrow sort of indicating that it feels like it's turning, but it also could simply be indicating the first compared to the second figure. There's one other way you could do this. It could be a flip. It actually feels a lot like the flip that we saw right here. So yeah, it could also be a flip. So this is one of those ones where I do have a second option. It could be a flip, and if it's a flip, then we would have the line that's actually the line y equals x, right? We'd have this line if we want to do it as a flip. So 2 different choices on that one. How about 3? That's a slide. Do you see the difference on that one, Emily?
Yeah, I thought the top one, the number 1, was like going away from me, so I thought it was like kind of like a 3.
Oh, yeah, that's okay. So yeah, number 3 would be a slide. There's nothing to indicate a direction or anything about that one. That doesn't happen on that. How about number 4? What is it? Okay, so it's a turn. That's a possibility. If it's a turn, how much of a turn is it? Yep, it's a turn, 180, or you could call it a half turn if you wish. We don't need to specify clockwise or counterclockwise because that's what 180 does, is it eliminates the need for that. Then the question is, could it also be a flip? What do you think? What do you think, Emily?
I put a flip because if you use the y equals negative x,
Okay.
it would flip. Yeah, it would flip like that.
Would it?
I thought it would.
It's tricky, so think about it. So I drew it in, and I know you can't really like fold my screen or fold your paper, but you could actually fold your paper. So if you draw that in and you fold your paper along that, tell me what happens. Julie's saying no. Yeah, it would actually end up looking like something like this. Oh, I didn't draw it well. It's not drawn well, but do you have the right idea? Can you see it if you actually try and fold your paper? Yeah. So when in doubt, sketch something to see if it will work. This one actually doesn't have the ability to do a flip. It's kind of a tricky one. Number 5, reasoning. Maria said the figures at the right, kind of look like flags, are related by a 90-degree turn. Paul said they're related by a 270-degree turn. Who's right? Explain. Somebody said it. Who is it over here? Julie? What'd you say? They both are. Tell me why.
Because it doesn't label which specific way you're turning the flag. So you can either turn it clockwise or counterclockwise.
Ooh, okay. That's good. So, yeah, you're right. So on number 5, both could be correct, right? It could be, let's say that we're starting with the vertical one, the orange to red, just so that we can have a reference point. So if we're going orange to red, what is it? Like, what could you say? Like, what would the 90 degrees be? 90 degrees what? 90 degrees counterclockwise. So it would be 90 degrees counterclockwise. But it would also be 270 degrees clockwise. So what we're saying visually is that this is a 90-degree turn if I go that direction, but it's a 270-degree turn if I go this direction. Right? Yeah. Yep, so either of those worked. All right. I think we have enough time to finish up. The last pieces are notes to take, but there's no examples to do. So let's actually just chat through them. Reflecting light off of a mirror. The angle of incidence is the angle formed by the incoming ray of light and a line perpendicular to the mirror. You can see all of them marked in our diagram. The angle of reflection is the angle between the reflected ray and the line perpendicular to the mirror. The angle of incidence is congruent to the angle of reflection. So in the diagram, they're talking about this angle and this angle being congruent, right? It bounces off in a congruent way. You've probably experienced something like that, whether it's specifically with light on a mirror or if you sometimes will get light that will bounce off your watch. Does that ever happen to you guys? And it gets over here and you're like, where's that dot coming from? And you have to sort of think through how it all got there kind of deal. The same thing happens when have anybody ever played pool or billiards? This same thing happens when the ball hits the side of the pool or the billiard table and bounces off. So when you talk about watching somebody or thinking about somebody playing those two games, pool and billiards, there's a lot of mathematics in pool and billiards because it's all geometric angles that are going on there. So it's very interesting. Our last one that we're going to look at is called a glide reflection. I know it was in the title. A glide reflection consists of a translation, a slide, followed by a reflection in a line parallel to the slide arrow. A glide reflection is another transformation that's also an isometry. So all the feet here are different colors. So if your original shape is the white one, then you see the translation moving into the blue. And then you see the reflection across the line underneath it moving into the yellow or tan color, right? And I wanted to share with you, because we have the footprint example, which is a perfect description of a glide reflection. In case you haven't heard it before, this is actually a poem called Footprints. It's pretty popular, but I wanted to share it. One night a man had a dream. He dreamed he was walking along a beach with the Lord. Across the sky flashed scenes from his life. For each scene he noticed 2 sets of footprints in the sand, one belonging to him and the other to the Lord. When the last scene of his life flashed before him, he looked back at the footprints in the sand. He noticed that many times along the path of his life there was only one set of footprints. He also noticed it happened at the very lowest and saddest times of his life. This really bothered him, and he questioned the Lord about it. Lord, he said, you once said that if when I decided to follow you, you'd walk with me all the way. But I have noticed that during the most troublesome times in my life, there's only one set of footprints. I don't understand why, when I needed you the most, you would leave me. The Lord replied, my son, my precious child, I love you, and I would never leave you. During your times of trial and suffering, when you see only one set of footprints, it was then that I carried you. So I don't know if everybody's heard that one before, but it's a really good one, going right along with our idea of these footprints.